As far as my talk today is concerned, I will only be speaking about scientific facts which have been established. I will not be speaking about scientific theories and hypotheses, which all of us know very well that many a time these theories and hypotheses, they take U-turns. In the field of astronomy, in 1973, there were a couple of scientists who got the Nobel Prize, and these couple of scientists, they described the creation of the universe, and they called it the Big Bang. And they said that initially our universe, it was a primary nebula. Then there was a Big Bang. There was a secondary separation which gave rise to galaxies, the stars, the planets, the sun, the moon, and the earth on which we live. This they called as the Big Bang. The glorious Quran mentions this in a nutshell 1400 years ago in Surah Anbiya, chapter number 21, verse number 30, the ayah I started my talk with. And it says, Avalam yaral lazina kafaru. Do not the unbelievers see anna samawati wal arda kanat ratqa fafataqnahuma, that the heavens and the earth were joined together and we clove them asunder. This verse of the glorious Quran speaks about the Big Bang in a nutshell 1400 years ago, which science has discovered recently. I will not be speaking about scientific theories and hypotheses, which all of us know very well that many a time these theories and hypotheses, they take U-turns.
The statement by itself, theory of evolution, means it's a theory. So by English language itself, you don't have to be a researcher. When you say theory, it's a theory. When the theory becomes a fact, it changes, that thing changes into a fact. So by the basic you saying theory of evolution, it means it's an hypothesis.
No.
It is not yet a thought. It's not yet a fact.
There's a difference between hypothesis and theory. A theory is something in science that has the highest honor. When something gains the word theory, it's fact. The theory, in theoretical terms, it's the theory of gravity, but we don't say it, we just say fact. Same way we say the fact of gravity.
Sorry, what did you say? Theory of what?
Gravity. If you say it in theoretical terms, but it's
no theory of gravity. It's a law of gravity. I'm sorry. I'm sorry.
It's the law of evolution.
I'm sorry. Your knowledge of science is very weak. It is Boyle's law. It is not Boyle's theory. It is Archimedes' principles. It's not Archimedes' theory. Whatever's theory, when it becomes a fact, it changes into law. I'm sorry, your knowledge is so weak, and I wouldn't like to continue. Your knowledge is so weak. I'm not here to teach 2 + 2 = 4 in the audience. In the question answer session, you ask a question, I give the answer. If you like it, you keep it. If you don't like it, you throw it.
Okay,
the thing is that if your knowledge is so weak, you're saying theory is the highest thing in science. I'm sorry, you're absurd. I'm a medical doctor. Theory is the highest thing in science. I'm very sorry, brother. I'm Jakir, brother. I'm very sorry. Theory is never the highest thing in science. If you think just because you're going to university or coming to fool the people here,
I'm not.
I'm totally sorry. Theory, if it becomes a fact, and if the theory becomes a law, it may reach a high standard. But theory by itself, it's a theory, it's a hypothesis. Once it gets converted, it becomes a law, it becomes a fact.
You know, the terms that we use in science are used very specifically in science as terms of art, but they have very different meanings on the street, and this is a source of a lot of confusion. When scientists talk about fact, they're talking about confirmed observations, and facts are interesting, but they're not terribly exciting. They don't do a whole lot for you. Facts are a dime a dozen. There's facts all over the place. A hypothesis is a testable statement. You're saying, you know, what's the relationship between this and this? And you go out and test it, and you either accept or reject your statement of that relationship. Hypotheses are very useful. They're very helpful. They help us build theory. Theories are the most important things in science. Theory to a scientist means explanation. And these are logical constructs of facts, of tested hypotheses, of laws, of all kinds of stuff that, taken together and put in a logical descriptive fashion, help us understand some kind of natural phenomenon. Most lay people think that theories are guesses or hunches or something that you don't have to take terribly seriously. It's not such a big deal. Completely opposite in science. Theories are the most important things in science. What a lot of, unfortunately, textbooks lead people to misunderstand is that a really good theory grows up into a law, as if theories are refined and then become laws, and laws are somehow more important than theories. In science, actually, what a law is a descriptive generalization. So we talk about the laws of thermodynamics that tell you about heat under different circumstances. You hear about the laws and study the laws of heredity that Mendel developed, law of independent assortment and so forth, because theories explain laws. So in general, the hierarchy of explanation is very different in science than it is in the general public. The general public puts facts on top, laws next, hypotheses, and then theories. Maybe theories and hypotheses can move around a little bit. In science, on the other hand, theories are the most important thing. Laws are next most important. Hypotheses are next most important. And perhaps the least most important part of a scientific explanation is facts.